Thanks, everybody. Let's get that review, but let's go ahead. We're recording it again. We'll hopefully won't have a failure on that recording. All right, so just going to Bridge Designer again. I'm going to go New Design. So this is, well, I'll walk you through this real quick. And then after I walk us through, I'll wait and we'll make sure we get everybody set to go, all right? Then we'll go together. So you just hit Next. I would just say the very first time through, just hit Next on each one of these things. Just go with the standard. Let's keep it simple to begin with. Let me go back here. So I go Next right here. So I've left all this the same. Then I'm going to go How We Trust. I'll hit Next. Now I'll put my name in there, Mr. D in this case. And I'm going to hit Finish. And that's what will pop up here. All right, and that's where I have it, right here. And we'll come back to the presentation in a moment. Get everybody do that, please. Set yours all up. And then we'll look at it together, all right? Let's see if I can squeeze my screens down so we can look at both at the same time. All right. Raise your hand once you have it. I can't press the next button. Aiden, I don't know why that won't work for you, buddy. Make sure you put a name in and you selected. You got to select that one last bridge. That might be the problem, Aiden. At what point can't you press the next button, Aiden? Aiden, at what point can't you press the next button?
It's just that the window is it goes off the bottom of my screen, and I can't drag it up, so I can't see the next button.
What? You've got to have some way. Maybe you can get a family member to help you. There must be a way to go ahead and shrink this thing, like this window here. You mean? Like the screen on the software, like I've got it right here.
Yeah, but yeah, the one before it.
Yeah, but right down here, can you go down and take the window and squeeze it tight? I mean, you know what I mean? Go up to the window on your PC and slide it over.
I tried to do that, but
Okay, if maybe run and see if you got a family member who can help you do that. Okay.
All right.
Because that seems strange to me. You can't do that. To be honest with you.
All right.
Are you running a Mac or a PC?
I'm on a laptop.
Okay, laptop is just a portable computer. Are you on a Windows computer or an Apple computer?
Windows.
Okay, well, I think up here in the top corner of it, somewhere you can make it bigger or smaller. I'm using a Mac right now, so I can't really demonstrate that.
Yeah.
All right, I'm going to mute you. Can you go see, can a family member go help you out there, buddy?
Yeah.
All right, I'm going to mute you right now. All right, everybody else, Keyshawn, have you gotten this far? Everybody leave your hands up, guys. Don't put them down, just because that way I can know if you've gotten it. All right, good. So people, all right, I'm going to presume we're all set here. And he'll get a family member to help him. Let me just show you. This is the same screen, all right? When you start to draw it, there's joints, there's members, there's pointers, there's erasers. I hope you all can see this. You click on the joints just like this, because I've selected the joints. Whoops. And I can use my eraser and go, there we go, back to my joints. Boom, 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 boom. You like that little special effect with my mouth? I'll show you. All right, and I would make it just the way they designed the first one. Get this to work, and then you can come on and you can make your own custom one for the competition. All right, this allows us to select members, and you click from here, hold your pencil out, boom. You have to connect from member to member to each. That was a silly statement. Collect the member to each of the joints. All right. And see, I'm doing it right here. So you can be doing the same thing now. Go ahead and start doing this. We're going to start playing with all this in a minute. You don't worry, and if you don't get it finished, I'm going to do it here quickly, and then we'll go ahead and we'll let you, we're probably going to have a pretty good chance for you to work on this while we're doing this. Let me get my eraser. I'm not sure I should have one there. There you go. Whoops. They can cross over, but they can't end on each other. I'll go do these right here. All right. You can draw them all at once. You can draw them individually. It doesn't matter on that. And I'm going to bring in this, make the screen a little bit bigger. If you notice, as I added these, I've got all these measurements on this side. So like right here, there's 7. All right, guys, can I get you to look at what we're doing now? Could you go over how to get there again? Yeah, you just simply go next, 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 Aiden, and then select this. I will try to do it for you. Let me see if I can save this so I don't have to do it every time. So I'm going to hit save. Okay. So I go File, New Design. So I just hit next, 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 and then I'm going to hit finish, next. Select through trust, Howie True Trust. Sorry. Next. Put your name in there and click finish. Did that help? All right. Now, guys, I'll give you a few minutes here in a moment and you can finish your bridge. Watch what we're going to do here as you finish it. What our goal is we're in design mode. It says it's unstable. Highlighted panel is rectangular. So in rectangle, they said there's a problem here with something we've done it. So, here it is. I forgot a member. So it will give you a warning. We have a little warning on there. So I say close. And it'll actually explain it. All right. So here we go. Let's try it. So it wants triangles everywhere. See, I didn't put one in there. So it did that. Now watch. Here's my bridge. Oh, boom, right into the water. Won't even support itself. Truck driver's smart. All right. So we go again. Go back here to design. That'll show you all your failures. See the ones in red? They fell under compression. The blue ones fell under tension. Okay? Compression is very sensitive to the length of the members. Shorter members are better. Compression, where tension is more concerned about the amount of the cross-sectional area. It's how solid it is. Where things under compression, the center can actually be hollow. So we can start looking at things we might change, okay? Also notice when we run this, look how red they are. See that? And if I, so the red, very red is failing under compression. The very blue is failing under tension. All right? Now, In fact, I'll tell you what, why don't you all finish your bridge right now, because I'm not going to have your attention. I'm sure you're working on your bridge. Raise your hand when you have your bridge all put together. So take your time. I'm here as long as we need to be here on this, so don't worry. But raise your hand, because we're waiting on you. Don't put your hand down, because we're waiting on you to see if as you work on your bridge. Let me see, I think I might have a question. What do we screenshot for the contest? Well, let me show you that. When someone just asked while they're waiting, you see that calculator up there? That's showing my cost. So what I want is a screenshot something like this, where it has that, your cost, and your name. You know, an honor above all. This is work you did. Don't get someone to do it for you. Okay, I only have 3 of 8 of saying the bridges, they're set on their bridge. Raise your hand if once you have it. All right. Yes, you can pick any design for the contest, as long as it follows the rules of this software here. I think that's great if you find that. All right, folks. Let's go ahead and walk. Let me show you the other things you need to look at. Now, even if you're not quite finished with this bridge, and then we'll come back and I'll give you time to work on your bridge tonight. But let's show other people how to work this. So let's look at the presentation software again. Up here, by collecting the select tool, you can select each member. It'll also show up on that far right. So here's member 36. It shows up here as a bar. It's 140, and then 566. We'll go with what those numbers down there mean in a minute. And this is where you run your animation. This will take you through the animation control. So you're in design when you're on this pointer, your animation when you're this. Failing, but that's okay. It's a simulation. Again, these you can tell the red ones are filing under compression, the blue ones are under tension. Red is a push, blue is a pull. All right? And then you go back here to the drawing board. You know, the old line, go, oh, back to the drawing board. All right. And this is right up here is a calculator. And then you have, by clicking on the member, it highlights in the load test results. So if you click it here to see which one failed, it shows you. So this one failed here, for example, there it is 1. And here we can change then the size to see if it's going to fail. to improve it. And we'll show you that in a second here. If you change to 150 by 150, those two members now pass. But why? Well, there is, because they're larger. For this class that will work, you do get into what's called moment of inertia, and that's idea is a way of a body's tendency to resist change. How much can it not change? And the bigger you get, the larger moment of inertia. It's just a general straight. Where inertia itself is an object in motion stays in motion, object rests. I call it the measureness of the lazy. I'm sitting here, I don't really want to move. That's inertia. And if I'm running, I don't want to stop because I'm already running. Who wants to stop? That's inertia. You just keep moving. An object in motion. Now, you don't literally make a decision, but it was one of the great insights in the last 1,000 years that objects, if it wasn't for gravity and friction, would just go forever. There's no reason for them not to stop. And we always thought their natural tendency was to stop. All right, now that's, we're going to jump through that. All right, let's change all these materials, all right, to a kind of material. We also can do things where we change the materials. So you can make it bigger. You can also change the materials. This material will get more expensive. See that calculator? It's constantly giving you a price. And you can look on these element channel, right? The periodic, and you see steel on there. And the answer is, of course not. Or maybe you wouldn't know, but steel isn't in period. It's not. It's an alloy. An alloy is a metal made by combining two or more metallic elements to give greater strength or resistance to corrosion. What do you think steel is? Iron and what? Any guesses? Raise your hand if you know. Oh, we got someone saying. Someone said coal. You're getting there. That's not too far off. Anybody else have got an idea? Well, let me show you. Carbon. So they put a little bit of carbon. Steel is a combination of carbon and iron. So we add a little carbon to our iron. It makes it stainless steel. They also introduce nickel and nitrogen and some other things. You know, and it's only less than 1%, is 1/4%. So you don't put in a lot of carbon necessarily. All right? And it starts to high alloy steel. So this carbon steel is $692 per meter or per 3.3 feet. The high strength low alloy, they add some other things into it, is $796. So this is stronger, but it's more expensive. So you're learning as an engineer, there's always trade-offs. And the engineers that can do the best amount of trade-offs are the ones we're going to get, all right? No, it would never be plastic. Yeah, plastic, no, but that's a nice guess. All right, now, and then quench-tempered steel, but now they put in special heating, is even more expensive. But if you have to use a smaller piece of it, it might be cheaper than buying a bigger, thicker, heavier steel because it doesn't hold. All right. By heating it and stretching it, they give it some elasticity. And we could get into that. Yield stress is the maximum stress that can be developed. And yield is, and when we talk about yield stretch is, imagine you've got the steel and you're pulling on it like taffy. There comes a point in taffy has very low yield stress. But most things, when you pull on them, they return back, right? But if you go beyond where it won't come back anymore, the rubber band snaps, the metal bends out of shape, the taffy bends out of shape, that's called yield stress. So, over here, you've got materials, you're going to change, there's this compressive force, and it's failing at 1.17. Change it to a hollow tube. That's good for compression. Solid bars are more for associated with tension. Why would we use hollow when we don't have to use solid? Save some. Why do you think that would be? It saves some cash. And I will save these notes for you, by the way. All right. Here's fixed with 2 solid carbon steels, cost $386. Fix these 2 with hollow carbon, saves you $380. You just saved yourself $6,000. Remember, these are in tension. Tension deals better with solid. They can be longer and they don't get worse. Compression, the longer it is, think of a longer ruler or meter stick. It really, if you push on a meter stick or a yardstick, it flexes in the center. Do the same amount of force on a ruler and you'll see it won't flex as much. Here's we changed to high strength alloyed steel. Change these 2 down here. And boom. Now there's your price though. It's up at 383s. It's the 51st iteration. That means you keep changing things and improving it. So you can start over. I started over. You can start optimizing this. You can figure out, well, how can I do this where I can be cheaper? All right. So let's do this. I'm not going to show you. I think we're getting close to overload. Let's everybody, it's now 7:30. Let's everybody get their bridge, run some tests, see if they can get it so their bridge doesn't fail. Let's take 10 or 15 minutes to do that. And then we'll come back and we'll go over some better ways to optimize the bridge. So let me go down here. Oh no, still some failures. Let's go back here. These 3 up here still failing. Let me know when you've got your bridge running, that your bridge is passed. Raise your hand once you've done that. Is it required we enter the contest? Heavens no. supposed to be meant to be fun and just give us something all to do and talk about. So you can talk, all right? If you get your bridge finished and it's working, see if there's pieces that you could make smaller that would still work. See, that's right if it's expensive the first time. I'm messing around with mine right now. All right, I'm at 368. $4,000. Nice. So we got the 40,000. All right, how many people, raise your hand, does anybody not have their bridge up and working or have a question about getting their bridge to work? I do want to show you some optimization techniques that'll speed you all along the process, okay? But if there was ever a thing I do, this is one thing I use with some of my high schoolers. We get on the method of joints. We get really into this. But this thing is really just about how much time you can spend on it. All right, let me show you one thing right up here you do as you get yours working. Can I get everybody to watch what I'm doing now? And then we'll spend 10 more minutes here showing you some things you can do to optimize it. And then you can work on it. We'll just wait, and I'll be here for you to work on it, okay? Let me see if there's any more. Make sure there's not another question. All right, great. Now, one thing you do is watch here. If I click on compressive forces, this is going those 0, 0, 0 on a compression forces, so that tells you they're all tension. The minute there's a value, you can see the tensions are now all zeros. So it can either be compression or it can be tension. It won't be both. And then you want to get it as close to 0.98 because that's as close to 1 without going over 1. Let me show you what I'm going to talk about. Say there's 13 right there. I'm going to make this 60. All right? I'm purposely lowering this. I'm going to run my test. It failed. If the truck stops. See now, these are all above 1. And this one's above like 35. So that gives you a sense that the minute it goes above 1, on that it'll fail. I'm going to go back to iteration 14. And now you'll see this bar right here, this 0.15, it'll pass because I'm going back to where it passed last time. So don't be afraid to go back on iteration if either the price goes up too much that passed the test. This will show you different results. It'll show you actually, you can copy this and save it. You can copy to a clipboard, put it up on a spreadsheet, the whole 9 yards. All right, now, so we can organize these. So what? First things first, I just did that. Let me go back here. All right? And you can do the same thing with tensile strength. So here's all the things that are very close in their tensile strength. And there's compressive strength. It also gets everything nice and organized, especially when you have your failures. All your failures are going to the top or the bottom. So that's the first thing. Also, if you click on more than one of these, if I change this, it changes it for both of those, okay? So let me go over here so I make this. So here's his optimization. He has his failures. If you click on compression, those failures will all be right next to each other, making it easier. See? They're all above 1. Get up below 1. If they're all above 1, they're going to fail. All right? You have to be 1, so it's less than that. And you can consider changing the size or make it shape or solid. Again, compression, hollow. Tension, solid. Compression, shorter's better. Tension doesn't matter. They're all affected by materials. All right. Again, this is failing 1.78. That one really needs to get changed. You'll also notice that you change one, it might impact the others in such a way that you may or may not even need to change them. So you want data, and you can look at it. Here's the yield stress. And again, this is here just so you can see it. We can actually break it step by step. You know, guys, you don't know what the modulus of elasticity is. Someday in high school, you know, in college you may, but right now don't worry about it. Someone said, I got mine be straight when the truck's going across. Yes, but what is the cost? It just has to cross. It doesn't matter if it sags a little bit. It might be cheaper that way. All right, now, this shows you these are failing in compression. The blue ones are failing in tension. Also, too, there's an issue with something called slenderness. Just watch over here. If it tells you it's got to stay below 300, that's really not a factor. It only gets in the freaky parts of the bridge. And if you go to help, you'll even get more math on what's going on to help this, okay? So let's go back here. I'm going to play with my bridge. I can get member details. Look at, give you a perfect idea. See, this member is, if it's in compression, is in red, right? Blue is tension. It never changes. There's the member length, and here's the strength. Notice when it's in tension, it never changes its strength, no matter what the length is. Here in compression, when it's short, like a foot, look how strong it is. By the time you get down to 12 foot. So again, compression is very sensitive to length. Tension is not. Compression is, you can have hollow tubes in compression. Doesn't matter. Good way to save money. Tension, it would matter. The materials you make it out of impact both of them. Okay? So these are all good things to remember. All right, now, so I'm going to take this. I'll go back to my member list. I'm looking at my costs. I'm at 368. What I'm going to do is go, well, look at all these, and I might concentrate on compression or tension, pick one or the other, doesn't matter. And I might go, okay, I'm going to go get all my compression ones. I'm all going to get them as close to one as I can, but I don't want them to go over one. That generally is cheap, as a way to make it cheaper. So here's 0.15. That's probably way overkill. Look how strong, it's probably very strong. It doesn't have much of a load on it. So with that in mind, I can make this one smaller. And I can go over here, see where this is? I can click it and make it a little bit smaller. Run a test. Let's see if it still works. We're in luck, it works. And I got my price down some more. Notice how it moved up here. It's now 91. So we'll go down to this one. Can I change this one? Maybe I can make it a hollow tube. Let's see if that's it. And I can look right on my calculator, see, does that save me any money? It did. Let's run it. Uh-oh. Got a failure there. See, that hollow tube, not so much. So I'm going to go back in iteration where it wasn't failing. All right, let me go back and look at this and go, well, I can't do it with a hollow tube necessarily. I have to make it a bigger hollow tube. So it's always these constant trade-offs and playing with it. And all right, that's a solid bar at that. Maybe if I made it 90 by 90, that went up a little, but now I make it a hollow tube. And still draw the price down. Let's see what that does. No, it still doesn't like it. All right. Remember, because there's two different iterations, I got to go back twice to figure out. So that's what I would suggest you start playing with. And if it fails, you can start to decide, well, can I, let's see, let's go, if I go to 75 by 75, I'll go 70 by 70. Let's see if that'll work. All right, got my cost down a little bit. It went up to 0.48, now 0.44, so I'm slowly lowering all this. And then you can just design anything else, all right? Any questions about doing this? And again, all I have to do is turn it in by next Monday before class Monday. Let's, I'll put out the time, but we'll do it, get it done by Monday. And post it on Edmodo. It's the only way. If you got the same, whoever posts first, say if there's a scores identical, whoever posted first would win. Take a screenshot so you can back it up, okay? And I think we'll put something out that will tell everybody that everybody has to have this done. I need just a little bit of time to check your scores, guys. And I actually need that for both. Let me think about that. It'll be Monday sometime. It may be Sunday at midnight it's done or something, and then we have Monday, so we have Monday to look at all the top scores. All right? Or we said Monday by the beginning of class. We could just keep it this way. Everybody can submit up to the beginning of class, and then we'll announce the winner then that Wednesday. Probably the easiest thing to do. We'll just simply say, yeah, at the beginning of class. Sorry for being a little strange. I'm trying to think the right, fair way to do that. Okay? Does anybody have a question? All right, there's a hand raised. Yes, Do you have a question? Yeah.
Yeah, you. Since you said about the screenshot and posting it on Edmodo.
Right.
I don't know how to take a screenshot on the Windows.
Well, on a Windows machine, just hit Command. I think it's print screen.
Okay.
It'll save it as a graphic file, and it really becomes an issue just that the winning team has got to put it up for everybody else to see it, their screenshot. So hit print screen, make sure you save it, save the iteration, and we can get it that way. Also, you can take a picture of it with your phone and upload it that way as a picture, I suppose.
Okay,
you bet. All you other Windows users, it's print screen, right, guys? I thought I used print screen on mine. I used to only use Windows machines. Now I've gone to Mac, and now I've gotten Windows dumb. But that's what we did in the past with it. My screenshots don't download. It's a graphic file. So what you got to do is go into your Paint program, open it up to screenshot, and save it. What you do is when you do a screenshot, this is coming back to me now. When you do print screen in Windows, it's saved to a copy clipboard, and it will open up if you open up the Paint program. I can't download my computer, and I have a Mac. Jason, all you do is hit Shift Control F4. It'll print the screen and just upload the graphic, buddy. It'll be a file. It will store right on your desktop. Just make sure the score you put up there is right. If we ask you for the screenshot, I'll walk you through on how to do it. All right? What's going on, buddy?
What?
Oh, you had your hand up. Do you have another question?
No.
All right. I'm going to mute you then. All right. If that's it, wait a minute. It's Shift, Command, 4. Yeah. See that little crosshair that just came up? You hit Shift, Command, F4. And then you can take a little cross shot like this, and it'll click it. Hit Shift, Command, 4. Shift, Command, 4. I think I said F4. I'm sorry. Shift, Command, 4. And you get this little cross diagonal area. And there it is. It's a great feature. You should learn how to do that with screenshots. Yeah, it does, Jason. You trust me on this. I'm running a Mac right now, my friend. Hit Shift, Command, 4. A little cross will come up. And then you pick the area, you highlight the area you want to print, and it'll click it and print it. and just Google how to take a screenshot in Chrome or how to take a screenshot in Windows, and lots of people have YouTube videos to show you how to do that. All right. So I can go ahead and get this webinar up here recorded and uploaded. I'm going to go ahead and do it for you. That's all I've got for tonight. The competition ends. The start of the lab next Monday. So enjoy it. And we're going to get going on probably 1, 2, 3D design next is what I believe is next. All right? So you're going to learn how to start designing things. All right. With that in mind, take care, everybody. Goodbye.